Hello, this is video one of Unit 1, and it's one of the most important videos because it starts with the foundation of all calculus, whether it's differential calculus or integral calculus. The limit is the foundation to both. So if you think of a house, you know how when you build a house, you have to have a strong foundation in order to build a house. The limit is that foundation. So I'm going to ask you to write in here to complete this first statement. The foundation of all calculus is the concept of a limit. Now, in this video, we're going to talk about what a limit is, how it's similar but not exactly the same thing as a point, a defined point. We'll talk about how to read limits and how to write limits. And then in the next video, we'll talk about how to evaluate limits using graphs and tables. So here we go. First video. What is a limit? I want you to think of a limit as being a destination. The limit is the y value that the function, whether it's in table form or whether it's in graph form or whether it's in equation form, but it's what the function, the y value that the function is getting closer and closer to as my x approaches a specific value. So let me tell you what I mean here. So when I look at this first example, I'm going to look at this x value of 3. So my x value is 3. The question is, what is the function getting closer and closer to as I squeeze towards that x value of 3? So as I move in from the left side and as I move in from the right side, what is the function doing? The function meaning the actual graph. What is the graph doing? Well, it's getting closer and closer to a specific y value, and that y value is 2. Now, here's where limits are not the same as points. Is there an actual y value at x equals 3? If I go to x equals 3 and I go looking straight up, is there a y value there? And the answer is no. There's an open circle. That means there's a hole in the graph. We call that a removable discontinuity or a point discontinuity. But doesn't matter. The limit exists because the limit was the destination of the graph. Whether or not the graph got there, whether or not the function is defined at x equals 3, really doesn't matter. What matters is where was it going? You can almost think of it as where was the function supposed to go, and then maybe it did, and maybe it didn't. I don't know. So in this example, we can see that as my x is approaching 3, as my x gets closer and closer to 3, as I move in this direction, the y's, or the function values, I'm sorry, I'm using the wrong color. I'm trying to remember how to use my pen again. The y's are getting closer and closer to 2. Okay, well, let's take a look at this one. I want to know what happens as my x's get closer and closer to 3. Now, if you haven't noticed, under these graphs, there's some statements, right? And this part of the statement tells you where to look. It tells you where or which x value we're going to focus on. We're focusing on x equals 3. So as I look at my example, I'm going to get closer and closer. I'm going to squeeze my window in towards x equals 3. What is the function doing? Well, the function is getting closer and closer, to this y value. So as my x's squeeze in, the function, in this case the graph, or if you think of it, the y values are getting closer and closer to this y value of 2. If you haven't noticed, that's the answer right here. That's the limit. The limit is telling me what was the intended destination of the function, in this case, the function graph. Where was it going? Well, it was going towards 2. Now, did it ever get there? Well, in this example, no. Is there a point at x equals 3? If I circle 3 at x equals 3, is there a point? Well, if you keep going up, oh, there is a point. But it's not where the function was going, right? So the limit is where the intended destination, the intended y value was 2. That's what we call the limit. Whether or not there's a point there, that's another question. That's another story. And so that's the difference between a point or a function value, the function value is defined exactly at a specific x point. So at x equals 3, there is a y value. As a matter of fact, I can write it over here on the side, and I can say f of 3 is 4. F of 3 is 4. Why? Because the y value at x equals 3 is where the point is, and the point is at y equals 4. But that's not where the function graph was going. The function graph seemed to be going towards 2. That's the limit. Sometimes they're the same, sometimes they're not. So we need to make sure to practice, and that's the purpose of this first unit, is to practice with limits to understand them, what they look like visually on graphs and numerically in tables of values. Let's do one more example. Here we're doing the same idea. If you look down here, I've been giving you hints. This tells you where we're going to focus our attention. We're focusing our attention as x gets closer and closer to 3. But where? Oh, on the graph. We're looking for the limit of the graph of h of x. So I'm looking to see, as I come from the left side, as I squeeze in, and as I squeeze in from this side, what's the y value that the graph is getting closer and closer to? Well, it's this point right here. And there is a point there, right? Like there's a closed part of the graph there. So in this example, the function value at x equals 3 is also 2. The limit is 2. The limit is where the graph is going. And the y value, where it actually ends up, is 2. That wasn't the case over here. By the way, I just realized I used the wrong name on the second example. The name is G, not F. But if you look at the second example, the graph was going towards 2, but that's not where it ended up. The actual point at x equals 3 is up there at 4. So there's a difference between a point, which is where does the graph exist at that x value, and the limit, what is the graph intending to approach or get to? What is the intended y value destination of the function? That's the difference between the two. And so when we look at the notation, we say we're going to take the limit of whatever function we're talking about, because our goal is to look at the graph and the y values. So let's take the limit of the function f of x, where as x approaches 3, and if there is an intended destination, then we write the value, and that's the limit value. So we read it as the limit of f of x as x approaches 3 is 2. That's it. Pretty easy peasy, mac and cheesy. We're going to come in the second video, and we'll take a look at some specific examples. But this is the first step into calculus, is defining what does a limit do? What is it really finding? It's a y value. It's always a y function value that the graph is getting closer and heading towards. Whether or not it actually gets there, that's another story. But if it's getting towards a specific y value destination, then you just found the limit.